Here are the answers for the section 4-9 homework. Starting with page 147, we're asked to divide. When you look at the question, there's a trinomial in the numerator, a monomial in the denominator. Because we're dividing by a monomial, the fastest way is to divide each term of the numerator by that monomial. This is called the distributive property. Take the 25x cubed term and divide it by the 5x. Now take the positive 15x squared term and divide it by the 5x. Now take the negative 30x term and divide it by the 5x. Now we're going to simplify all three of these terms. 25 divided by 5 makes 5. X to the third divided by x to the first makes x to the second. We're subtracting exponents there. In the middle, 15 divided by 5 makes 3. X to the second divided by x to the first makes x to the first power. And then on the last one, we'll have negative 6, and there won't be any x's at all because this x and this x cancel away. Number 3, let's use the same technique because we're dividing by a monomial. So take the first term of the numerator and divide it by the negative 8xy. Take the next term of the numerator and divide it by the negative 8xy. Take the next term of the numerator and divide it by the negative 8xy. If you want, you can use plus symbols to separate your terms, but then you'd have to associate the negative sign with the 24. And again over here, if you put a plus sign in the middle, you'd want to put a negative sign with the 64. Now let's simplify each term. 16 divided by negative 8 is negative 2. X to the third divided by x to the first makes x squared because you're subtracting exponents. 3 take away 1 makes a 2. In the case of y, the y cancels away. Now over here to the middle, we have a negative and we're dividing by a negative. That makes positive. 24 divided by 8 makes 3. X squared divided by x to the first makes an x. Y squared divided by y to the first makes a y. Now on the end, we have negative divided by negative. That makes positive. 64 divided by 8 is 8. X divided by x cancels away. Y to the third divided by y to the first makes y to the second. Number 5 is the same. There's a trinomial and we're dividing by a monomial. So use the distributive property. 3a to the fourth divided by negative 3a squared. Minus, now 3a cubed divided by the negative 3a squared. Plus 3a squared divided by the negative 3a squared. Now simplify each term. 3 divided by negative 3 is negative 1. A to the fourth divided by a squared is a squared. In the middle, negative divided by negative makes positive. 3 divided by 3 makes 1. A to the third divided by a squared makes a to the 1. Now on the end, positive divided by negative makes negative. 3 divided by 3 makes 1. And a squared divided by a squared cancels away. So here's the answer, unless you rewrite it without the 1's, because it's not typical to show 1 as a coefficient. Number 7 has the same format. Let's use the distributive property. Distribute the division of 3a squared to all three of the terms. 12a cubed divided by the 3a squared minus 9a squared divided by the 3a squared plus 3a divided by the 3a squared. Then simplify all three terms. 12 divided by 3 is 4. A cubed divided by a squared is an a. Minus 9 divided by 3 is a 3. A squared divided by a squared cancels away. Then a plus. 3 divided by 3 makes a 1. And a to the first divided by a to the second, when you subtract the exponents, will leave an a in the bottom. Because there's more a's in the bottom to begin with, when you subtract them, any a's that are left over will be left over in the denominator. Number 23, we are not dividing by a monomial this time. Our denominator has two terms. We're going to use long division for this one. We're dividing y plus a into the y squared plus a squared. One of the smaller details that we discussed when talking about long division in the video was that the polynomials need to be written in order of decreasing degree. We have a y squared term, but where is the y to the first power term? That's not shown. So let me erase my a squared and fill in a 0y as a placeholder. Then put the a squared. Now let's start dividing. We're going to look at the leading term there and the leading term there. Y times what is y squared? That would be a y. Now multiply what you're writing up on the top by the divisor out in the front and write the result under here. Y times y is y squared. Y times a is ay. Now you see why I needed the placeholder, so that I could get this y term lined up under a y term. I don't want the ay to be written under the a squared. Now let's subtract. Y squared take away y squared cancels away. 0y take away ay makes negative ay. Bring down the next term. Focus on leading terms, the y and the negative ay. Y times what makes negative ay? It would be negative a. Now multiply this thing that we just wrote down by the divisor out front. Negative a times y is negative ay. We wanted these to match. Negative a times a is negative a squared. Now subtract. These cancel away. A squared subtract negative a squared makes 2a squared. I cautioned you in the video about being very careful with the subtraction. This is positive 1 and we're subtracting negative 1. Use a calculator if you need to. A positive 1 subtract a negative 1 is a 2. This is our remainder. So our final answer is y minus a plus 2a squared over y plus a. For number 25, we're also dividing by a binomial. Let's use long division. X plus a divides into the x cubed plus a cubed. But let's use some placeholder zeros. X cubed plus 0x squared plus 0x plus a cubed. By using the placeholders, this will help us to line up the terms in columns for our subtractions. Focus on leading terms, the x and the x cubed. X times what makes x cubed? That'd be x squared. X squared times x is x cubed. X squared times a is a positive ax squared. Now subtract. These cancel away. 0x squared subtract ax squared is negative ax squared. Bring down the next term. X times what makes negative ax squared? We would need a negative ax. Because negative ax times x is negative ax squared. Negative ax times a is negative a squared x. Now subtract. These cancel away. 0x subtract a negative a squared x is positive a squared x. Bring down the next term. Focus on the leading terms. X times what makes a squared x? That would be an a squared. a squared times x is a squared x, and a squared times a is positive a cubed. When you subtract these, you get a remainder of 0. That tells us that x cubed plus a cubed divides by x plus a evenly with no remainder. Here is our answer on top of the long division bracket. There's actually another way that this problem could have been done without using long division, and the other method works because it does divide evenly. So it's not really part of this section, but let me just show it to you. X cubed plus a cubed is a sum of cubes, and therefore it factors with the small set of parentheses and then the longer set. We get x plus a, then x squared minus ax plus a squared. And our denominator was x plus a. Notice we now have a common factor in the top and bottom, and those common factors cancel away. Look what's left over. The same answer that we got with long division. The factoring method to divide only works when the original problem itself will divide evenly. Otherwise, you won't have matching factors that cancel away. For the review assignment, we're going back to page 145 where we were graphing inequalities. We want to have a 0 on the right side and then factor the left side. I notice that the left side is not in the right order. Let's put the highest degree term first and then put the n term. Now factor out negative n, leaving n minus 2, and that's less than 0. We have two factors multiplied together. The result is less than 0, which means negative. For the answer to a multiplication problem to be negative, one of the factors must be negative. There are two cases to consider. The first factor might be the one less than 0, and I'm using the intersection symbol just to shorten up the writing of the word and. The second factor could be greater than 0. Or, now case number 2. The first factor could be greater than 0, and the second factor might be less than 0. Let's go back through both cases and solve these inequality statements. For this first one, divide both sides by negative 1. The arrow will switch. We're still left with 0. Over here, add 2 to both sides. Now think about what this statement is describing. N is a number that's greater than 0, and at the same time, it's greater than 2. This could be written with the single expression, n is greater than 2. Now let's go over to case 2 and solve these. Divide both sides by negative 1. The arrow switches when you divide by a negative. On this one, add 2 to both sides. Our statement is n is less than 0, and at the same time, it's less than 2. This could be written with the single expression n is less than 2. Now we can graph. We want to show n is greater than 2 or n is less than 2. So here's 2 with an open circle. Greater than 2 means shade it to the right, and less than 2 means shade it to the left. So everything got shaded except the number 2. Number 4, we already have the 0 on the right, and we already have factored form. Let's consider the cases. Case number 1, when you multiply two things together and the answer ends up greater than 0, meaning positive, they both might be negative. So y plus 2 is less than or equal to 0, and y minus 3 is less than or equal to 0. Or, now let's consider case number 2. The other way that two things multiplied together can end up greater than 0 is if they are both positive. So y plus 2 is greater than or equal to 0, and y minus 3 is greater than or equal to 0. Now let's go back to both cases and solve the inequalities. Subtract 2 for both sides. On this one, add 3 to both sides. Now consider this statement. Y is a number that's less than negative 2, and at the same time, it's got to be less than or equal to 3. we could write the single statement y is less than or equal to -2 for that description. Okay, over here on this one, let's subtract 2 from both sides. And right here, add 3 to both sides. Now think about what this is saying. Y is a number that's greater than or equal to -2, and at the same time, it's got to be greater than or equal to 3. We could write the single expression y is greater than or equal to 3. Now graph both of these parts. Here's -2 with a closed dot, shade to the left, and here's +3 with a closed dot and shade greater than, which is to the right. Number 6, we already have the 0 on the right side, but we don't have factored form. So let's go s plus 5 times s plus 2. I went with 5 and 2 because they times to 10 and add to 7. Okay, we have two things times together. We want the answer to be less than 0, which means negative. Case number 1. The first expression might be less than 0, and the second one might be greater than 0. Or, now case number 2. The first expression might be greater than 0, and the second one might be less than 0. Now let's go back and solve all of these for s. This is s is less than -5, and s is greater than -2. Let's think about this. What kind of numbers are less than -5, and at the same time, they're greater than -2? There aren't any. This is an empty set. Okay, now over here, subtract 5 from both sides. And on this one, subtract 2 from both sides. We want numbers to be greater than -5, and at the same time, we want them to stay less than -2. -5 is our lower boundary, and the -2 is our upper boundary, and s is in between. This can be graphed. Here's -5, here's -2. They both get open dots, and the shading is in between. Number 8, we already have the 0, but the left side is not factored. Furthermore, I notice that the left side is not in the right order. Let's put the -u² first, and then put the +36. Because the leading term is negative, let's factor a negative out the front. The u² minus 36 is a difference of squares, and it factors. Now let's divide both terms by -1 to cancel the negative away. We're left with u plus 6 times u minus 6 is less than or equal to 0. The arrow switched because I divided by -1. We have two things times together, and the result is less than 0. So there are two cases. Case number 1, the u plus 6 could be less than 0, and the u minus 6 could be greater than 0. Whoops, I meant to say less than or equal and greater than and equal because of the extra bar on the symbol. Now case number 2, the u plus 6 could be greater than or equal to 0, and the u minus 6 could be less than or equal to 0. Go back and solve them all for u. U is less than or equal to -6, and u is greater than or equal to +6. What kind of numbers are less than -6 and greater than +6? Nope, there aren't any. That's an empty set. Okay, now down here, u is greater than or equal to -6, and u is less than or equal to +6. This is possible. This is telling us that the lower number is the -6, and the upper boundary on u is the +6. It's telling us u comes between those two numbers. So on the graph, we have -6 and +6, closed dot on both, and shade in between. Number 10, we don't have a 0 on the right, so let's subtract 6 from both sides. Then factor the left side, m minus 3 times m plus 2. I went with these numbers because negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. We have two cases. Case number 1, they could both be negative numbers because a negative times a negative is greater than 0. Or, now case number 2, they could both be positive numbers. Now let's solve for m everywhere. We get m is less than 3 and m is less than negative 2. This can be combined to the single expression m is less than negative 2. Here we have m is greater than 3 and m is greater than negative 2. Numbers which are greater than 3 and at the same time greater than negative 2 could be written as m is greater than 3. Let's graph both of these parts. Here's negative 2, here's positive 3, open dot, shade to the left, and on this one an open dot and shade to the right. We discussed this observation the other day. When you have an inequality with a greater than, the graph has the branches to the left and to the right. It's when you have the less than symbol that you get the section in the middle. Okay, we're going all the way back to 126 where we were simplifying. So in number 5, we're multiplying powers, and both powers have the same base x. The rule is to keep that base and add the exponents. Number 16, we are dividing, and we have the same base. The rule is to keep the base and subtract the exponents. This makes 4 to the negative 2s power. Another thing we discussed at the time was we don't leave our answers with negative exponents. This is equal to 1 over 4 to the positive 2s. It's possible to skip this step here if you pay attention to the subtraction at the beginning. Go back to the original problem. In the top there's a 1s, in the bottom there's a 3s. As soon as you decide that you need to subtract the exponents, pay attention to which has more. Is it the numerator or denominator? The denominator has the higher exponent. So when you subtract them, the leftover s's are in the denominator. Page 127. Again, we were working with the power rules at this point in time. So in number 18, we have several things in parentheses, all being raised to the 4th power. The technique is to distribute that exponent to all those factors. So start with the 3. 3 to the 4th power is 81. Now the a, we get a to the 4th power. Now the b squared. When you raise b squared to the 4th power, you get b to the 8th power. Okay, in the denominator, very similar. Take the negative 12 and raise to the 2nd power. That makes positive 144. Now take a squared and raise to the 2nd power. That's a to the 4th. Now take the letter b and raise to the 2nd power. That's b squared. Now we're going to simplify. Is there any number that divides into 81 and it divides into 144? They both divide by 9. 81 divided by 9 leaves a 9. And in the bottom, 144 divided by 9 leaves us 16. So the fraction 81 over 144 reduces to 9/16. Now the letter A. What do you see about the letter A? We have a to the 4th on top, a to the 4th on bottom. What's going to happen? They cancel away. Now the letter B. What's going to happen? We get b to the 6th power. How do we get that? To divide variables, you subtract the exponents. 8 subtract 2 makes an exponent of 6. The answer is 9b to the 6th over 16. Number 23. This first section is similar to what we were just doing. We have a product in the parentheses, all being raised to the 2nd power. So distribute that power to all of those factors. 2 to the 2nd power is 4. Then x to the 2nd, then y to the 2nd. Now after the plus sign, we have a whole bunch of things times together. So let's multiply these all together and then later do the adding. Negative 2 times 4 is negative 8 times negative 3 makes 24. We have y times a y, which is y squared. And we have x times an x, which is x squared. Are these like terms? They are, so we can combine together. 4 plus 24 makes 28, x squared, y squared.